Hello students, in this video we shall deal with the centroid derivation of different geometrical shapes. Before going for any geometrical shape, we shall derive the general equation which is required for the same derivation, that is derivation of centroid for a irregular lamina, which will fetch you the formula which is necessary for the derivation of any geometrical shapes. So as you now know the definition of center of gravity as well as centroid, which will be represented simply as G or Cg. Till now, you might have derived with the moment of force. So if you have a force F and a particular point O, where you need to find out what is the moment at O. So moment at O is calculated in such a way that perpendicular distance from the point O till the line of action of the force is calculated, which may be taken as X. And now the moment of force at O is equal to force into perpendicular distance X. So this is how you were calculating moment of force. Now, in this case, that is centroid is important to find out in such a way that you have to find out the moment of area or moment of inertia. That is, here you need to calculate what is the moment of area. If you are given with such a irregular area, first you need to find out the centroid in such a way that you need to find out the moment of this area. So you can't take this entire area into consideration. I have to get a single point within the area. So single point within the area can be taken as a centroid, where the definition of centroid is the entire mass of the area is concentrated at a particular point. Let us say this is a point which is considered as centroid or G. So now I have got a single point from where I can refer the perpendicular distance. So now I have a point within the area. So this area is having a single point where entire mass of the area is concentrated with, that is G, for which I have to find out the moment. That is, moment of the area is nothing but moment is equal to nothing but area into perpendicular distance. Now the perpendicular distance is from this point, particular point, till the point where you are considering. Now here in this concept, instead of point, I'll be having a axis. Instead of a point, I'll be having a axis. Let us consider I am having a y. I should refer the perpendicular distance from the point G. So that distance is calculated as x bar. That is a perpendicular distance from the centroid of the lamina till the axis of reference. Now it is y-axis, so I will take the distance as x bar. So this is the concept how to find out the moment of area. So instead of force here, I'm taking area. Since I'm taking area, I can't take any random point within the area to find out the perpendicular distance. So I'll be choosing one point where the entire mass of the area is concentrated. That is nothing but centroid. So if I want to find out the moment of area, I need to have a perpendicular distance here, that is x bar, to which I have a requirement to find out what is G. So that is why you are going to derive this center, or that is derivation of centroid of any irregular lamina or any geometrical shape. I hope you have understood. There will be a lamina which is having a concentration point which is nothing but called as centroid. I call it as G. So if I have a reference axis, let us consider now it is y. So the perpendicular distance from the centroid till the reference axis y is taken as x, since the reference axis is y. Now in the same way, I may have another option also. I may be having a axis of reference that is x like this. So if it is axis of reference x, the same centroid is having a perpendicular distance of y bar from the x reference axis, which will give me the moment of area, that is area into y bar. Area into y bar. So the determination of centroid is by the method of moments or method of integration or first principle of moment. So to understand about first principle of moment, we require a diagram which has a lamina. Then let us consider a lamina of irregular shape like this, which has a total area of value A. Let us consider it is having a total area A. So it is a irregular lamina. We shall consider it is having a centroid at this point. Consider it as G. We don't know the position, but we will assume the centroid is somewhere here, which is taken as a G. So this G is referred from the axis X and Y like this. So if I have a reference axis X and Y, so this G will be at a distance of X bar from Y axis, and this G will be at a distance of Y bar from X axis. So this is a case. So this is a irregular lamina whose centroid is G, which is having a coordinate of X bar and Y bar. You can see that G has a coordinate of X bar and Y bar as per the axis of reference. So to find out the general equation, the same lamina, this is the same lamina I'm considering, which is having a centroid of G here. So same lamina can be divided into n number of elemental strips. So this can be divided into n number of elemental strips. So let us say that I have divided this entire lamina into 5 elemental strips. 1, 2, 3, 4, 5. 5 elemental strips. So there is no necessary that I have to divide it as 5 elemental strips. As you increase the number of elemental strip, the centroid position whichever you will get for the entire irregular lamina, that will be exact point. So I need to divide this into n number of elemental strip. Here I have divided into 5. So I have divided this one into n number of elemental strips, whose area is considered as A1, A2, A3, A4 and A5. So I am having this lamina wherein the reference axis will be same. I will be taking X and Y as a reference axis, where for this different areas I have to take the centroid. For this area of A1 I'll be having a centroid. Let us consider it as G1. The same thing if I consider for A2, I'm having a G2 as centroid, A3, G3, A4, G4, A5, G5. So these are the centroid point of every elemental strip A1, A2, A3, A4. So if I am having a centroid like this, definitely this centroid is having a different coordinates, or it is at a distance, perpendicular distance from y-axis, which can be referred as x1. In the same way, x2 for G2, x3 for G3, x4 for G4, x5 for G5, and it will be at a distance of perpendicular distance of y1 to x-axis from G1, y2 from G2, y3 from G3, y4 from G4 and y5 from G5. So these are the coordinates of every centroid. So you can say that this entire lamina is divided into 5 elemental strips. So if I want the area, that is total area here, this is total area, that is nothing but addition of all the areas of elemental strip. correct? So it is, now I have divided into 5 elemental strip to A1 plus A2 plus A3 plus A4 plus A5. So it, I can write or reduce the equation as sigma AI, where I is equal to 1 to 5 now, or in general I can write it as I is equal to 1 to n, correct? In general I can write it as 1 to n. So this is how I can obtain the total area here. In the same way, and we are having the elemental strip in such a way that it is having a centroid G1 with the x1 and y1 as coordinate, G2 with the x2 and y2 as coordinate, G3 with the x3 and y3 as coordinate, G4 with the x4, y4 as coordinate, and G5 with the x5, y5 as coordinate respectively for the elemental strip, correct? So these are the coordinates of the elemental strip which you are considering in the figure. First, the principle of moment states that moment of total area about the axis is equal to sum of moment area of individual strip about the same axis. Now I have two axes of reference, one is y and x. The same lamina is divided into n number of elements here. So this is the total area, original lamina, and this is the same lamina divided into 5 elemental strip. So you can say I can, for example, I'll consider only the reference axis y. Let us imagine that this x reference axis is not there. So moment area of this entire total area A at about the axis y can be written as, how can you write? So moment area is nothing but area into perpendicular distance. So if you are writing for the this entire figure case, so moment area is nothing but area into perpendicular distance. Now it is x bar, correct? This total area into perpendicular distance of that area till the axis of reference. Now that area means you have to consider the point of concentration of entire mass, that is nothing but centroid, and from there you have to measure the perpendicular distance, which I have taken here it as x bar. So this will be the moment area of total entire lamina whichever you are taking. So this will be equal to, as per the first principle of moment, it states that moment of total area, this area into perpendicular distance about the axis, now I have taken y axis, is equal to sum of moment area of all the individual strips about the same axis. So you have to get the sum of moment area of every elemental strip to the same axis. So it will be sum of areas. So let us start with the first elemental area. Area A1 into perpendicular distance to the y-axis is from this G1 till here. So it is A1 x1 plus A2 x2 plus A3 x3 and plus A4 x4 plus A5 x5. So this is the first principle of moment. So it can be written as, since A is, I can write it as sigma AI into x bar is equal to, I can reduce this equation into, so this equation can be reduced into summation of AI xi, correct? So this can be reduced into summation of AI xi, or else I can find out what is x bar, where sigma AI xi divided by sigma AI, correct? Where I is referred from 1 to n number, or you can say infinity, n number of elemental step can be used. So this is how you are finding x bar. So this is a general equation you have to remember to find out the derivation of any geometrical shapes. So this shape is now irregular shape. Further derivation will be there for a particular geometrical shapes like rectangle, triangle, right angle triangle, semicircle, quarter circle, circle, all those things will be there. So for that derivation, this x bar, general equation of x bar is required. So this is how we have obtained the equation of x bar by considering only one axis. In the same way, let us imagine that y-axis is not there, only x-axis is present. At that time, you apply what is the first principle of moment. So again, it is total area into perpendicular distance, that will be the moment area of entire total area of the irregular lamina, that is A into y bar, will be equal to summation of all the moment area of all the elemental strip to the same axis, that is whatever I am considering x axis. So summation will be, again the equation will be moment area of total lamina will be equal to A into, now it is y bar, correct? Since we are referring x-axis here, x-axis, so that will be equal to summation of all the areas, that is moment area of all the elemental shape to the x-axis. So we are referring to x-axis means the perpendicular distance will be area A1 into y1. So it will be A1 y1, A2 y2, A3 y3, and A4 y4, A5 y5. So this will be the equation where I can reduce sigma AI for the total area into y bar is equal to sigma AI yi, where I'll get the general equation y bar is equal to sigma AI yi divided by sigma AI, where I is equal to 1, 2, 3, and it will go up to infinity. So this is again the general expression when considered for x-axis. Remember that these two equations are very important, and y bar, you will get y bar when it is reference for x-axis. You will get x bar when it is reference for y-axis. So in the next video class, we will deal with the derivation of centroid of geometrical shapes, starting with the rectangle. Thank you.